Welcome to AVN channel. Today we will study about the electric current. In previous topic we have already studied about the formula of resistance and formula of the specific resistance. So here we will study about the temperature effect on resistance of the conductors. According to the temperature, when we raise the temperature, resistivity or specific resistance formula we have already studied. Rho equal to m ne square upon tau. Tau is a average time of collision, and when we derive the formula already, L upon A and R equal to m L n E square tau A. So basic concept is here R is inversely proportional to the tau, because when increase the temperature all factors will be remaining constant, the major factor will be changed, that is the tau bar. When we increase the temperature, tau bar will be decreased. It means when we increase the temperature of a conductor, the molecules of conductors move very fast and the timing will be decreased. Because when we increase the temperature, suppose this is a conductor, and when you increase the temperature, the molecules of this conductor will be increase, the molecule will be move very fast when temperature is increased. So average time of collision will be decreased. When average time will be decreased, then the resistance will be increased. So the basic concept, the temperature effect of the resistance. Here the temperature is proportional to the resistance, because when we increase the temperature all factor will be constant, the major factor will be changed, that is the average time of the collisions of the molecules. So here when we increase the temperature, collision of the molecules will be, the timing of the collision will be decreased. When timing or average time decrease, the resistance will be increased. So here the basic concept is when the temperature is increased, resistance is also increased. The basic concept is when we increase the temperature, resistance is increased. So here I am taking a conductor, and this conductor initially resistance at T0 or T1 temperature, that is R0 resistance. At initially temperature, we can consider 0 degree temperature or any initially temperature, that is T0, and resistance is R0. When we increase the temperature, suppose increased temperature is T2, the temperature is increased T0 to T2. It means the resistance is at this temperature is RT. The resistance will be RT. RT is the temperature at this resistance is increase or decrease, that will be depends on the increasing the temperature and decreasing the temperature. When the initially temperature, the resistance is initially. When we increase the temperature, the resistance is RT. So the basic formula, the difference of the resistance RT minus R0 is inversely proportional. The basic concept is the initially temperature, the initially resistance. At when you take the another temperature, the resistance another. The difference of the resistance this difference of the resistance is proportional to the initially resistance. This is the equation first. The difference of the resistance RT minus R naught is proportional to the R naught. When RT minus R naught is also proportional to the delta T. And what is the delta T? Here delta T equal to difference of temperature, that is you can take T1 minus T2 or T2 minus T naught. The basic concept is the difference of the temperature that is proportional to the difference of the resistance. Here difference of the resistance is proportional to the initially resistance and difference of the resistance is proportional to the temperature difference. So we can write RT minus R naught is proportional to the R naught delta T from equation 2 and 3. Then we can write R naught delta T. When this is a proportional sign, this proportional sign I take a constant, that is alpha. This is sign, the proportional sign. This is proportional sign, this is proportional sign, and here I am taking alpha. Alpha is not proportional sign, this is the alpha constant, and R naught delta T. And what is the alpha? Alpha is a constant that is called by the temperature coefficient of the resistance. This is not proportional sign, this is the alpha. Alpha is a proportional constant of temperature. So here RT minus R naught equal to alpha R naught delta T, and you can write RT equal to R naught plus alpha R naught delta T. So we can write, when you solve RT, so RT equal to R naught plus alpha R naught delta T, and when taking the R naught common, then RT equal to R naught 1 plus alpha delta T, and we can direct alpha. What is the alpha? Alpha equal to RT minus R naught upon R naught delta T. So this is the temperature coefficient of resistance, that is the alpha, and alpha is a new quantity. So what is the unit? Dimension and quantity. The unit is resistance, and resistance is cancel out, and degree centigrade inverse or Kelvin inverse. And what is the dimension? Dimension, when you write with theta, then you can write theta inverse, or when you take the temperature in degree centigrade, the unit will be degree centigrade inverse, that is Kelvin inverse or degree centigrade inverse. This is the quantity. Quantity is scalar because this is a constant quantity. So what is the temperature coefficient? Here temperature coefficient RT minus R naught upon R naught delta T. So you can write unit is degree centigrade inverse or Kelvin inverse. And what is the impact of temperature coefficient on the conductors? When the temperature coefficient of conductors vary on the metals, when we take some examples, this just like nichrome, magnesium, that is the manganese, and constantan. When we take the alloy of the metals, the temperature coefficient will be decreased. So nichrome is nickel plus chromium, that is the 20-80 ratio. I am not taking in compositions, but here what is the alpha? Alpha is the less quantity, that is the degree centigrade inverse. Constantan is the alloy of copper and zinc. And what is the manganese? Manganese is also 10 raised to the power minus 3. Nichrome is 0.4 into 10 raised to the power minus 3. So here these alloy is 10 in degree centigrade inverse 10 raised to the power minus 3. When we taking the superconductor, the mostly conductor is silver, and silver is also 10 raised greater than this temperature coefficient. So here the temperature coefficient of alpha is less, that is the constantan and manganese. And in our physics lab, when we study about the potentiometer and potentiometer wire, that is used, always take the constantan or manganese. Why it is used? Because when we flow the current in the conductor, suppose this wire is constantan and a wire is copper. When you flow the current, what is the effect of this temperature coefficient? The impact of temperature coefficient is when we flow the current, the wire will be heat. So we will always generally use the constantan or manganese in the physics laboratory, in the potentiometer or other various experiments. So constantan wire does not heat due to the flow of current because the temperature coefficient is very less. So here when we flow the graph between RT and R, temperature and resistance for the conductors, here the increasing the temperature, when you increasing the temperature, resistance is also increased. So this graph will be follow, that is, this is the R naught and the graph between RT, and this is the temperature T, and this is theta. This is generally take the graph at the high temperature. At very low temperature, this graph follows like this, RT and T at the low temperature. And here when you use this y equal to mx plus c, then you consider this graph at the high temperature. This graph is generally at the low temperature. So this tangent will be very less at the low temperature. When the temperature is increased, this graph is follows. So the conclusion is that the temperature effect of the resistance as conductor, when we increase the temperature, resistance is also increased, and the alloy temperature coefficient of the alloy will be very less according to the experiments. When we increase the temperature, the conductor should not be heated. So this is the temperature effect of resistance of the conductors. Thank you for AVN channel, and kindly subscribe this channel, and if you have any problem, kindly comment. Thank you.